source code, because the physics of my thing is not, it feels like there is something off with it, and I don't really understand why, because it seems like I'm doing the equation, the correct equation, but it feels off because the nodes don't pull or push each other, so in the way that I think they should. And also I have a problem with the event listener that I have there when I drag the nodes, because I have to set their position, and if I stop moving the mouse, then the node begins teleporting because the physics simulation is still running, but the mouse is fixed on a position, so the node goes off the mouse position. And then when I move the mouse again, it teleports back to the position. So, and this, like, it got me thinking about switching or changing the physics engine that I'm using, which is Raptor.js, to use Box2D or some other physics engine, because it might be a problem with the physics engine, and I can spend a bunch of time studying the source code, but then it's gonna be like very hard, I think, to make it happen. So it might be better to switch to another physics engine. But then I got me thinking that, like, what I want to achieve is exactly what VisJS does. So the only reason why I'm not using VisJS is because I think that I can make it faster by using WebGL. So when I use Pixie.js, or actually try to build WebGL from scratch, because I think it's going to be faster, and from the graphs that I tried to do it on the past, with VisJS, if you have thousands of nodes, it becomes a lot slower. So that's the reason why I want to do with like another way. But I'm trying to do a very similar thing that VisJS does, pretty much the same thing. So I think I'm going to study now. Today I'm going to study the source code here. And I already spent a bunch of time studying the source code of VisJS, but I'm going to try to emulate what they do and just copy as many things I can from the stuff that they are doing here, and then try to switch so that it works with Pixie.js or WebGL. And then I slowly transition to try to build everything from scratch without using any library. It's going to be very hard, I think. So it's going to take a lot of time. And then here I just copy the function that VisJS uses to calculate the spring forces. And also I realized that they put the comment for the reason why the distance that I didn't understand before. The reason why they have the distance here divided by the distance is so that they don't use sine or cosine. But I don't understand really well why. Obviously sine and cosine is related to the distances calculations. You can use sine or cosine to calculate the distance, but they are using this formula here, which should be enough to calculate. So I don't really fully understand why they divide by the distance here, but I think I'm just gonna try to do it exactly the same way that they do it. And the other difference is that they're not adding a force to the body, they're just changing the position. And another thing that they are doing differently is that they are running this at each step on the physics engine. And I was just running on the beginning. So that's another thing that is confusing to me, that I asked a question on Discord, but I couldn't get an answer. That it's very hard to think about what is the correct way to split the responsibility, let's say, because like what kind of stuff you should put on, you should just run once in the beginning and then let the step of the physics engine recalculate everything, and what kind of things you have to recalculate at each step anyway. But it looks like the spring forces you have to recalculate each time. So and I'm putting the functions here now, and I think that I'm going to change the names of the functions so that they are the same as it is on VisJS as well. And the other thing that I realized is that on their code they have the spring length, and I realized that this is the same thing as the rest length from the other example that I was using. So it's pretty much the value that you're gonna put to make the force equal to 0 at certain length of the spring. So it's just an arbitrary value, and I wasn't because they do it with options, so I didn't understand really well. And here they are passing half of the edge length, but then on the physics engine options, they have here at some points the spring length. So it's pretty much what they are using. And the other thing that I realized that it's different than the stuff that I have so far is that they are using a bunch of solvers, which are this repository solver, hierarchical, or Barnes-Hut solver. And I think that these things make the calculations or add forces to the bodies that make it feel very different than the stuff that I have right now. So I think what I'm gonna do is just try to study from the event listeners what happens when I change the values here and when I click or move things on the graph there. I'm gonna put some music, hopefully it doesn't cut the stream. I don't think I'm gonna code much, I'm just gonna step through this, try to understand how they do it. Maybe I should create here I should create files for the solvers. I think I'm gonna copy all of the solvers and then just copy the functions and try to implement on my own stuff there. It's probably a good idea. I think I'm just gonna start with one solver. I think from the graphs that I did so far, the Barnes-Hut solver seems to be the best one to visualize stuff, so I'm gonna start with this one, I think. And then I'm gonna try to emulate their physics engine class as well, I think. The more I study about this stuff, the more I think that VisJS is very good, the way that they did it. The only downside is that they use the event emitter and then it's hard to understand. But I really like the way that they did things. Makes a lot of sense. The other thing that I was doing and I didn't do yet is to go over the execution from Pixie viewport to create the events of drag and zoom, and then just copy the functions. I was gonna do that, but I think I'm gonna do it from VisJS instead of Pixie viewport. And I think what I might do as well is just I created I put a bunch of folders on the other thing that I was gonna do here. I think it might be a good idea to create a simple project from each one of them and then try to create very simple animations and things like that with each physics engine, so I understand more how it works. I think I need to implement in the easiest way possible to see, so I can see how can I get the feel that I'm going for, which is just springs, and it doesn't feel right on the way that I'm doing there, but I don't really understand why, because the equation seems to be correct. But it's just that when the simulation starts, the nodes are not, it doesn't feel like they are pulling to each other, and they the springy behavior, they go apart, and it seems like there is no force, but I'm adding the force and changing the values as well, so I don't understand really well why it doesn't work. I think I have to remove the breakpoints that I put here. And then I'm gonna add these ones. So I did this one time already, and it's interesting that I think it's gonna be, the node's gonna be selected. The way that I think that they do it is that after you select, it's only gonna unselect, let's say, on the pointer up, I think. And that's the difference from the way that I'm doing there. So that way the node's always gonna be connected with the mouse, but also probably the way that they are calculating is different as well. The position, the way they are changing the position of the node is different. And that's the issue with Wrapper.js, I think, because in the documentation of Wrapper.js, they say that you should avoid as much as possible changing the position of the node, because that breaks the simulation, because it's like teleporting the node. But the issue is that any events that I'm going to put, I'm going to have to change the position manually, because I think it doesn't make sense to just change the force, because then I have no control over the mouse input, I think. Yeah, here it stays connected with the mouse. I should try to implement one thing at a time on my stuff there. It's hard because everything is connected and hard to know, like, but I think I understand. They initialize everything on the network class, then they pass a bunch of options, and then based on the flow here, it's gonna decide how it works. Oh, the other thing that I can do is put breakpoints here. I don't remember last time. I think that the issue is that last time that I did this, I didn't understand really well anything. Like I was just in the beginning. I didn't understand, and I was trying to understand it based on the codes after it's compiled on the Webpack code, and I didn't understand that how it worked. So now I think it's gonna be much easier to understand, because I can just put the breakpoints here and then I can just go over everything, like, and maybe I should do the same thing that I did for VisJS. I think that makes it a lot easier. Hopefully I'm gonna be able to do this soon programmatically. That's the goal, I think. But yeah, I think that might help a lot. So I create these flowcharts here by following the execution of VisJS, and then try to copy this stuff as much as possible on this thing that I'm trying to do. See if it works. And the thing that I was thinking about doing is just doing, because I don't need to add the forces. I can change here just the position, and all I need is the bodies. So or maybe we put node one body. I think that's how they do it on VisJS. They just change the X and Y positions based on the solvers, and they don't add the forces. It is difficult to think about or to decide if I should use a physics engine or not. Yeah, the thing is, I have to understand if they use a physics engine or not. I think that the issue that I had before with studying VisJS is that they use a Vis dataset, which is another. So the way that it works, and most of these libraries seem to work this way as well. So probably there is a good reason for that, obviously. But I think that the main reason is because the way that the libraries evolve over time is that before, in the beginning, they don't know how it's going to be applied, and then as the library evolves, you create these different packages. So most of these libraries have a bunch of Git repositories. The bigger the library is, and then the different repositories communicate with each other. So I think that the Vis datasets is another repository, and then they use that, and I couldn't find the source code for the way that they shape the data. So like you pass the data, then it becomes this Vis dataset, and these are the nodes and the edges, and then based on that, there's classes there as well to also manage the nodes and edges, and then from those classes it creates the physics and everything else. But I don't know if they are using a physics engine like Raptor.js or Box2D or something like that, or if they are just changing the values of X and Y based on the classes they have to store the data of each node. Also, I think they use 90 here for the rest length, and then 0.04 for the K. So I'm gonna try to put the same values that they do. Let me think. Oh, I'm already passing the body, so. And this is the thing. Now, obviously I'm doing something wrong, but what exactly? Because it has to do with the physics engine, so. And this is the issue, is that I don't understand very well how the physics engine works. And then to understand, because the documentation doesn't explain very well. Like they explain the basic stuff, but how, like, what exactly is happening under the hood at each step of the simulation? It's probably because of the objects, like, because I'm making this equal to a variable and then I'm changing the value of this variable, but the value of the body itself is not changing. So that's, I assume that's the reason why it's not working there. Also, I think that I can set the translation. I have to set the translation instead of adding like this, and then I have to create the... Maybe that I'm gonna try to do that after. I think this is not gonna work. So I think that if I want to emulate VisJS, I have to change the physics engine, or not use a physics engine at all. Just use custom classes that keep track of X and Y positions, and then just change the positions. Because I think that they don't recommend like to do this, to change the positions. I think like, yeah, it's a different way of thinking, let's say. I think that the way that VisJS approaches is that they just change the positions and that emulates the forces. But the way that this works is that the library creates all this stuff for you, and then instead of changing the positions directly, you should change the physics, but then it doesn't work really well. And like, I don't understand what is the correct way to change the values so that it follows the same approach that they are doing. Because it doesn't make sense for me to change the values of the physics on the interaction. The other thing that I don't know is that if I can do operations on the vectors, or if I have to do the operations myself, the code. Because the other libraries, they have methods after you create the vector, but it doesn't seem like they have here. So if I want to multiply two vectors, for example, do I have to do manually before I create the vectors? But then what's the point of creating the vector? Is it just to pass as like an argument to the other ones? I don't think that wrapper is bad. I think it's just a different paradigm of thinking, of doing things. Maybe, I'm not even sure about that, so. Might be because I don't understand really well how it works. Why isn't it working here? This is the other thing that I don't understand. It might be because of the scale. I think the numbers are off. This K here seems too small for the coordinates that I'm getting, and I think it might be because of the way that it gets the coordinates. VisJS might be getting the coordinates from the relative positions, and here is absolute or something like that. So it makes the values, the magnitude of the values be very different. What can I do about this? Yeah, so it should be oscillating. If it goes lower than 90, it becomes positive, and higher it becomes negative. And then this multiplied by the distance between them creates the force. That's the issue. Maybe I shouldn't set translation, and I should just set the linear velocity instead, or something like that. Forgot how to, what is the method. But the problem with that is that if it works, then like the issue is how do I create the events, because on the events I need to keep track of the position. I need to change the position manually. That's the biggest problem, I think. I set link val, I think. Okay, so now it seems to work. The issue is this one. This one is working, this one isn't. Oh fuck. I remember, maybe if I go back to the way that I was doing before. So something wrong. That's math max, I think. I'm confused with Python, I think. It looks like now it's working, but if I click here, it fucks up. Because I have to change the position manually, I think. And then if I change the position, it's gonna mess up the calculation on the engine, I think. Like it works, but if I keep holding now, it fucks up. Or maybe it's the way that I have to like set up the variables on the events. Maybe on the mouse down. I think that's the stuff that I need to understand with VisJS. And now it doesn't work anymore. Yeah, this is the weird thing, is that like it doesn't sync quite right, because now it's just pulling towards this node and not the other one. So it's probably because of the way that I'm calculating here on the events as well, because I don't know the order of the nodes. And this is the stuff that is confusing me, is that like what order I'm supposed to choose, because they're gonna change it every time. So like the position of the two nodes are gonna change each time, and the order is gonna matter because of the direction of the force. So if I don't know like the direction of the vectors in the initial position, how can I decide which one should I subtract and which one should be positive so that they attract instead of repelling each other? That's the problem, I think. So one thing that I was doing before as well, that I try to do, is just put conditions to see. So I make sure that the values are always positive, let's say. So check which value of x is higher, and then do the calculations like that, because that way it's a lot easier for me to think about, because then I can always structure the logic based on the position of the two nodes. So I can know which one is on the left and which one is on the right, and then based on that I can put the forces so that they are always attracting to each other. But it doesn't seem like that VisJS does it like that. They do it based on the distance, and I think that it's not easier, but it's probably better to do it like that. But I just don't understand really well how it works. Because if the directions are, if the position of the two nodes are changing all the time, then why is the force always attracting? Obviously they have two different values, but then like, isn't that gonna depend on the vector? That's the problem, because if fx is negative and fy is negative, and this is the left node, then the force is gonna be repelling the other node. So if that's the case, then this force should be positive and the other one should be negative. And if the position of the two nodes are different, then it should be the other way around. So I don't understand like how that's supposed to work, I think. Maybe I should go over with the debugger and try to understand how it works with this one. And the other thing that is difficult to understand is like, because I think that they're using a different physics engine, or the way that they're doing the physics is different. They probably are not using a physics engine, I think. They're just calculating the positions. So it changes the way that I have to think about it. Before, I think I was adding a force and velocity as well, I think. I was adding a force and impulse. I think they tell you to add impulse if you want to change the velocity, or acceleration or something like that. Yeah, apply impulse. Maybe I should try to do that again. See if it makes any difference. I think the biggest thing that is confusing me is the direction of the vectors. That's what I don't understand really well. Because if I make based on the position, then depending on where the nodes are at, the force is either gonna repel or push or pull. I don't remember the word. But obviously I always want to make them attract each other, so this is the issue. And now it fucks up the thing as well if I move here. So I don't understand why this is repelling and the other one is pulling. Why doesn't this one pull towards this one? It should be the same thing. So how can I test this or figure out? I think it's just because of the... Maybe I should just try to do it again with the conditions to see if the X and Y are bigger. Then depending on that I make the forces negative or positive. That way it makes sure that they are always... I think that it's probably the difference is that the reason why VisJS works is because they are adding the position, adding or subtracting. So regardless of the direction, is always going to be the same effect. Because then the positions are going to be either negative or positive. And because I'm adding the force, then the force changes because it is a vector, so it changes on the position. So I have to put the conditions, I think. But I think that the last time that I did this, it wasn't working as well. It works, but not... It feels there's something off, so... That's what I'm trying to figure out. Is I'm probably doing something wrong. I think I'll be right back. I think the way that I'm gonna do it is by separating by nodes on the left and on the right, and up and down. And that's the way. But I don't understand why on VisJS they don't do it like this. But the way that I'm thinking about it is that the load on the left is gonna have a positive force, and then on the right negative on the fx, and then the node on the node up is gonna have a down force, and down is gonna have a positive. So I think that's the reason why it's fucking up, because here I'm also using the same sign for both of them, regardless, so... Yeah, but let me think about it. It's just annoying to think about the conditions to put. Because also the coordinates, I think, are the other way on the browser. It starts as positive and then goes down, becomes negative, so it's the reverse. But I think I'm just gonna do it like the standard way of thinking about it, and then I just change the values later, the direction. Yeah, but let me think, what is the best way to do this? I think the distance doesn't matter, maybe, because it's always going to be a positive value. So here is going to be negative, but then it's positive because of the calculation. Yeah, but obviously it's going to matter if I calculate like this here. I always want a positive value. But maybe that's why... Maybe it should work without putting the conditions, because then here is going to be negative, so... It's just confusing to think about. Let me think. Yeah, I think I should do it like this, and then I pass this here as well. And then I just change the values. So fx is always going to be positive, negative is negative, obviously. But I think that's not gonna solve the thing. I have a feeling. I'm still gonna feel weird. And I have to understand why. And maybe it's better to just change the physics engine that we're using, or not use the physics engine at all, and just try to do exactly the same way that VisJS is doing. Because I don't want to waste a bunch of time on this, I just want to focus on the other stuff that I have to solve. Let's see. And so that way, make sure that they are always positive, the values. So fx is always going to be positive. But then how do I know? Yeah, I think that it's probably better to put here, because I have to determine which node is up and which one is down. And then based on that, I have to add the forces here. Which one is up and down and which one is left or right. So, trying to think what is the best way to do that. I think that's probably... Yeah, but then I can't put this stuff before because I need this to calculate, so... I think I'm just gonna put the condition again. Because I need this, I need the distance to calculate the force, I need the difference to calculate the force and the distance. But then I need again to determine which one is at which position. Because I want to make the direction of the force to be based on the position. So if the node 1 is, if the x is greater, then it means that it's on the right. So I make -1. And the x is always going to be positive. And then obviously I'm going to change the sign if it is different because of the browser. I think I'm just gonna do it like this, see if it works. I'm gonna think about it later. So if it's greater, it's up. So the force has to be down. It's pretty much the same thing. Now let me think about it. It's gonna be the opposite. It's always gonna be the opposite, actually. So I can do this outside. I guess it doesn't matter, now that I think about it. Because obviously the conditions are gonna take care of the direction of the vector. And this is what I mean, that's probably something else that I'm missing. And then I don't even need this thing as well. I can just do it. Because if it is always positive, yeah, but then it doesn't matter anyway. That's the thing. It matters because of the x and the y, but because the force is going to be dependent on this value, so yeah, but if they are always positive, then yeah, but I need to know which node is on which position to. Maybe it does matter. Maybe I need to put the conditions here as well. That's the thing, the x might be always the... Yeah, I think I need to put here. Because you can have a situation where the next x has to be... No, but actually it doesn't make sense. Because they're always gonna be the inverse of each other. Yeah, I think that this takes care of... Because I was gonna say that there might be the case where one of them has to be the opposite of each other, but the other one is the same direction. But I think that doesn't make sense. They're always the opposite. But the problem is that if the dx or dy is always negative or positive, then you might fuck up because one of them might have to be negative for one and positive. So, but they're always the opposite. So. Might be the case that this is negative and this is positive, but then here is going to be the opposite. So this takes care of that, I think. And before, I think that the issue is that they will always have the same sign regardless of where the nodes are at. So this making this condition here, I think it changes. But maybe this is necessary as well to know which one, at which position they are at. Now let's see. But looks like it's fucked here. So let me think. So if node 1 x is greater or equal to node 2, that means that node 1 is on the right, node x is on the left. unless it's inversed, but let's do the normal way. So that means that 1 is greater, so the x is going to be positive. And the other way, the x is going to be positive as well. So there's always a positive value. So if here, if the node x is on the, so this should be the other way, I think. Because it should be, no, let me think. Yeah, it should be negative, so maybe but then I have to do the opposite, because if the node 1 is on the right, I want the force should be to the left. And if the other is the other way around, then it has to be positive, and the other way is just going to be the other sign. But like it seems to be correct, so I don't understand why it's not working. And then here is going to be the same thing, but so if node 1 is greater, it means that is on, I think it actually means that it's going to be down, so the force is up, and the other way around, the force is down. And then here I always use the positive forces, and here the inverse of the, because it has to be on the other direction. I think that this should work, but for some reason it's not working. Oh, now it works. Let's see here. Yeah, but here, maybe it's because of the rest length. So maybe now it works. Yeah, but this is the weird thing, because now this one is, it doesn't seem like it has any force. So I don't know what's going on. I think it might be because of the way that I'm looping over them there. Because that's the problem, I don't know which one is which in the beginning. Like I don't have the directions of the nodes in the beginning. That's the issue. So when I calculate them in the beginning, I'm passing one node as the first argument and the other as the second. So here it might be the other way around, and then that fucks up the calculation. But I also don't understand why though, because oh, it could be the values here, but it's not, it doesn't make sense to be the values. It's something else, I think. I think probably has to do with the set translation thing here. Because it should generate some force at least, either way. So one of them stops moving, that's the problem. There's always one that stops moving as well. Interesting. Let's see if I stop resetting the forces. Oh, now it seems that it's working. The thing is, I think that this step takes care of the forces if I don't update them, but maybe not. And there's still the problem that it's not gonna it's not gonna work if I move the mouse and just leave the thing, because the forces are still active even if I'm holding the nodes in place. So I need to find a way, because I can't change I can change the position, but I can't make the... Maybe if I remove the forces for that node that I'm holding, but then on the... And maybe if I call on the up event to add forces again, and I just stop... Yeah, but this is the thing, because how I'm gonna make it so that... I think I have to create another function, and just on the other function just select the forces that are being applied, or maybe I just reset the forces for the node that is being active, or that I'm clicking, and then I set the forces again on the up event. That might be the way, I think. Yeah, I think that's probably the way you should do it. So now it looks like it is still working. This is the weird thing though, because... And that's the reason why I think it feels off. Because when I pull here, it should pull this node towards the other one. And now I fucked up this one. But maybe if I leave the calculation there, it's gonna work. But I don't understand why this happens. It's probably something to do with this translation, setting translation here probably fucks up somehow. Yeah, but it's still weird because it pulls this one towards this one instead of pulling both of them towards each other. But maybe it's because of the force on the other one. Maybe that's why. Yeah, but here it's fucked now again. This is what I mean, is that like, I think it's probably the physics engine. Something with the way that the physics engine works. Because I don't see like how I'm making a mistake here when creating the forces for the bodies. Maybe it's because of the order of the nodes as well. It could be that, but that wouldn't make sense because I'm putting the if statements there now. So regardless of which one is on which order, it's gonna check to see their relative positions, and then the force should be always like pointing towards each other if it is working on the beginning. Because it's either gonna attract or repel because of the signs. It can't be any other way because I'm checking now to see the orientation of the forces. So it shouldn't matter the order that I put them here. And I don't understand why. The only explanation should be the set translation here. Somehow changing the translation might fuck up the physics engine, I think. And the other weird thing is this, that it seems that it attracts a lot more one of the nodes towards the other one, depending on which node it is. But I guess it depends on the physics as well, because if you pull, then there's the velocity. So there's the velocity and the force, and then it might be because of that, and the orientation of the nodes. Yeah, it might be because of that, I think. So maybe it's correct this way. Yeah, maybe this is correct, actually. Because it is pulling now, so... The only thing that I have to solve is I think I should reset the forces. Yeah, but if I reset, it's gonna fuck up the other ones, I think. Maybe I should do another function than just... because I want to remove the forces on the body that I'm clicking, which is this one. So that regardless of how long you hold, it's... So let me think about it. And then I add the forces again here on the up. And this is the problem, because I'm gonna have to loop again. This doesn't work. Because when I hold, it keeps going. And now I fucked up this one. Probably because yeah, when I reset the forces, it fucks up, I think. Maybe not. Maybe it just feels off because of the difference in because VisJS doesn't use a physics engine, just changes the position. Because here, when I pull, like all of them are, and it feels a lot that is like a lot more natural this way. Because the way that I'm doing, it seems like one of the nodes is kind of broken when I click. And this is what I mean, is when I let go of this one, it goes back. But it might be just because of the magnitude of the... Yeah, but here, like, this one is not pulled towards the other ones. That's the problem. When I let go here, only these ones move. But maybe if I remove again, it is the correct way. If I don't reset the forces. But it feels like there's something off. And now it's pulling towards each other. So maybe this is correct. Just... yeah, maybe this is correct actually. The only thing I have to see is this. How do they make it so that regardless of how long you select, it doesn't go back, it doesn't move. So how do they achieve this? It's only when I let go, it's... And I think this might be like an issue with the physics engine, because it's the whole set translation thing. Maybe I'll have to switch physics engines. Unless I make it so that I calculate the opposite forces for the nodes, and then I don't have to set translation. It's like, yeah, but then it feels like it's overcomplicated, that's the problem. So I can make it so I can add different forces on the node that I'm selecting to make it so that the physics of... it kind of stops the physics for the node that I selected, and everything else remains the same, but it feels off to do this. I'm gonna just step through this again, I think. Try to understand how they do it. Which events? Maybe I should do the click event instead of the... Yeah, I think that's the thing. The last time I saw was with the click. And I think it might be slightly different. Depending which one I put here. I should do it with all of them probably. Why is it not working? What? Maybe it's because I have the other one open. This one. I don't understand why it's not stopping. That's weird. Oh, maybe it's because it doesn't have the click event. That's probably why. So it only stops on other events. And the click is for outside, maybe? But I remember... Yeah, there's something else going on. What's happening? Why is it not stopping here? I think if it doesn't work, what I'm gonna try to do is just to put breakpoints in the beginning when it initializes the network, just see and step over all the process. And now it works. Maybe it's the pointer down or drag down, something like that. I want to understand how they do the selection so that because obviously I have to, it's buggy if I leave the way that it is now. I want to make it so that the node stops regardless of how long I have the mouse over. Because right now when I move and then I stop moving but I'm still clicking the node, it goes off the pointer. But I'm probably gonna have to think about either I'm gonna have to change the physics engine, I think, or I have to think about how to add the forces in such a way that it's gonna make the node, whatever node I'm selecting, to like stop moving in relationship to the other ones, and then keep the forces on the other nodes. It's probably, but I don't understand why the reset forces. I think the reset forces don't work because. But it should work, because the other nodes should have the forces to attract to the one that I'm holding. So I don't understand really well why it doesn't work there. There's some way that I saw, maybe just mouse down or something else, or drag. I don't know why it's not working now. I guess I can look for the events manually through the files as well. That's what I'm gonna do. Probably it's better to just see in the beginning, like the whole flow of the network, how it initializes everything. Then after that, I try to put the breakpoints on the events that I'm looking for. So obviously it uses the should classes here, selection handler and interaction handler, to handle the logic of the events. And the question is, how does it make it so that the node that is selected is static and the other ones still move? I think after I figure the other thing that I have to try to implement from this is that I'm probably not going to use pixie viewports. It's just going to be, I think it's going to be easier to try to implement the ones that they have here, is the drag and wheel event, the zoom, and because here it works exactly like I want it to. So I think that the next thing after I figure this out of how to keep the node static, regardless of how when I stop clicking, then I'm gonna try to figure out the wheel events, the wheel and the drag. But I think first I need to understand, because the issue with the drag is that it's hard to know, because if I put mouse move, it's not gonna be like, it's gonna be the collection of the 3 different events. I think one event should signal when when you click, the other should signal when the mouse moves, and the other when the mouse is up. The combination of these 3 events is the thing that creates the drag. But the problem is that I don't know specifically which ones they're using to hold the logic. So the way that I think that it always works is that you have flag variables, and then based on these variables you change the values of the x and the y, which is the delta of the mouse, and from the flag variables you decide the logic that is gonna change the physics engine to move the nodes. So it's just a matter of figuring out how the flag variables are changing. But this is a problem, because there you can see that they have this .drag or dragging.drag, something like that, which is the flag variable that they use, I think, probably. But then that depends on everything else that is happening. So like, I don't know a good way to put breakpoints without knowing specifically which events they use, to understand like the whole flow of the thing, of how it works. But I think I'm just gonna try to copy, get all the functions that they use here for each thing, and then just put the functions on the project that I have there, and then try to implement, just change the flag variables until I get something that works. But I think now probably the best thing to do is just put the breakpoint on the network, and then try to understand exactly what happens after the network is initialized. And then from that, try to put breakpoints on all of the event listeners and then try to interact with the thing. Just see what happens. I think the wheel is the easiest. And the other difference is that obviously they're using a normal canvas, so the way that I'm gonna have to change the canvas is different as well. But I think that for that I can look at I can try to combine both of them, the VisJS events and the Pixie viewport events, and see where exactly the calculations are different, because I don't think that it is that hard actually. It's just now that I understand how Pixie works a lot better as well. The hardest part is thinking about the physics engine, I think. Because obviously when you scale, it's going to change the position of everything. And I think that there isn't a better way than just recalculate everything every time that there is the wheel event. You have to recalculate the position of the whole network. Because the physics engine is going to require that to calculate the colliders and the bodies. So this is the problem, because I think here, by changing the zoom of the ratio of the canvas or the scale of the canvas, it changes everything else automatically, but maybe not on the physics. But this is the flag variable that I was talking about. Okay, I don't know during the whole flow of execution of the thing how this is gonna change. I want to see here if they are changing the values of the nodes or just the canvas. Yeah, that's how they do it. When they request redraw, it's gonna call the function that is inside of the request animation frame loop. And that function is going to recalculate everything on the nodes and the edges, but I'm still not sure if that changes the values on the physics engine. That's the thing. I think because it changes when it's redrawing the nodes, it recalculates the position of everything. And that automatically changes the physics engine, because the physics engine that they're using is not really a physics engine, it's just changing the positions of the elements to represent the forces. So it's different than the way that I'm trying to do it, I think. Because the way that I'm trying to do, I'm gonna have to recalculate everything, I think. Or I'm gonna have to recreate. Yeah, maybe the best way to do it is just to separate the functions that I have here when I'm initializing everything. Because I'm gonna have to recalculate regardless, because I have to change all the rigid bodies and the colliders to represent, I have to change the radius and the position to represent the new scale, I think. Yeah, but I think all I have to do is just put the... Yeah, but the problem is that I can create different functions that just change the bodies based on whatever happens, I think. So I don't need to recreate them, I'm just gonna set the new positions by the delta. That's what I'm gonna do, I think. Yeah, so just copy everything that they do, and then the only thing that I'm gonna have to do differently is just loop over all the edges and nodes. And then I call the set methods of each one to set translation and set everything else to represent the new state, I think, by the delta. And this is the biggest difference, I think. And for this, I can just copy the Pixie viewport functions. But the way that they change the world in Pixie.js, I think is gonna call a bunch of nested functions on classes, and that's gonna call the update transform or world transform, something like that. That does the calculations on the matrix to change the size of everything. But here it just changes the methods, like it's easier because it just changes the things on the campus, and it's only X and Y, I think. And Pixie doesn't have Z, I think, as well, but because it's using WebGL, it has to do different calculations. So this is just calculations to draw. Try to see if I get the physics calculations. I'm concerned about skipping because I might miss something related to the physics. But this is just recalculating everything to draw, like redrawing everything based on the new positions. I want to know how they synchronize the physics with the visualization. But it might be better to just step over since the beginning, just see how everything is structured, like how the physics work in the beginning, and then go back to this to see how it changes. I think I might do some more coffee. I wanna step over everything before I stop streaming. And I think after this I'm not gonna stream for some time, and I wanna watch all these videos here that I have about this. It's very hard to find videos about this, which is the stuff that I'm trying to understand more, how to synchronize the painting, the drawing with the physics. But I think watching some of these videos hopefully will help. And also I have to contemplate more on whether or not it's worth it to test the other physics engines and do like a basic project for each one. To see, because it might be the problem here, I think, that maybe I'm trying to do this stuff like right away without doing the simple thing first, which is to just create like a very simple project and then just do the simple visualization. But like, I don't know if I want to do that because it's kind of annoying to set everything on the beginning. I think it might be better to do that once I'm trying to recreate Pixie from scratch, because then I'm gonna have to do the simple stuff anyway. Like this setup, I think is kind of annoying to do it. But I think that's with the stuff that I have now. Maybe the thing that I was missing was the direction of the forces there, and now it's working like in the way that it should. Like the reason why I felt it might be the case that the reason why I think that is kind of off is because VisJS also has the other. It has like the other calculations for it has this Barnes hut solver and the other things. So I think that might be changing the way that the simulation feels, and that might be the case why I think there is something wrong, even though there isn't on the stuff that I'm doing here, because it feels kind of off when I pull the thing, but maybe it's the correct way. And the only thing that I have to figure out is just this thing that's when I hold the node. But here, like, this is the thing that's weird, is because sometimes it feels that is correct and sometimes it feels that is not, because the nodes don't move. And I don't understand really well, because it seems like the calculations that I'm doing here are correct. Like just to add the forces. And this is the biggest issue, because then that's the reason why I'm debating like what direction to go. Because in order to truly know if there is something off or not, I have to understand how the source code of the physics engine works. And this is the reason why I think that it might be better to just create other projects from scratch and then just do the simplest visualization that I can by applying all these forces and stuff like that until I get something that works in the way that I think it should work, because then I'm gonna have a reference frame to do the other stuff. Because here I might have to spend a bunch of time just trying to understand the source code of this stuff here to see if it makes sense or not, or if I'm missing something, or if I'm doing the correct thing and it's just a problem with the... It's just a difference in the way that the physics engine works. And so maybe the best thing to do is to understand VisJS first, because what I'm trying to emulate is VisJS, but using WebGL. So maybe I should understand first like how they do it, and then from there I decide whether or not to create other projects. And like maybe I don't need the physics engine at all. I just create my own classes, or I try to copy the stuff from VisJS and just try to change, which was the stuff that I was doing in the very beginning. The biggest thing to understand is the synchronization between physics engine and the drawing, and also how the calculations change how the drawing calculations change from Pixie.js from WebGL to the normal canvas. That's the two main things I think I have to figure out. And then once I figure that out, then it should be easy to just do the same thing that VisJS does, but with Pixie. So far just stuff about drawing, nothing related to the physics. I think we're just gonna step over. Oh, fuck. Now let me put the breakpoint in the beginning and just step over everything. Since the beginning when it creates everything. Then I go back and try to understand the events. I think first I need to see like every event that it sets up, and then after that I put breakpoints on each one of them and see. I have to think about what is a good way to, because I don't want to put only the breakpoints in one of the events. I want to be able to see the whole flow of the thing. everything that happens during. I have to think about a good way to think about that, sure. Because it would be a lot better, obviously, if I could like specify an action that I want to emulate and be able to visualize or debug everything that is happening through the execution of that action, instead of just putting the debug on the events. Let's see if I do like this. Hopefully stepping through here is gonna show me the functions on the dataset as well. I think I'm gonna make more coffee and I'll be right back. And when I come back, I'm gonna step over this. I think I'm gonna stream until I step over all of this and set up breakpoints on the events. And then I'm gonna probably go over the events off stream. And I have to think more about whether or not it's worth it to do other projects or just keep trying to change the stuff on the project that I already have to see if I can get closer and closer to VisJS. But it might be better to just start from scratch and then see if I can emulate perfectly, like without having to think about all the bullshit about React and the whole flow of everything else. Like just try to, on a clean project, go from VisJS to whatever framework I want. And then from that template, I integrate that template on the stuff that I'm trying to do. I think that might be better. Bro, back. I changed my mind. I think I'm just gonna do some meditation for around 15 to 20 minutes, I think. And then I'm gonna go back. I think I'm gonna do 15 minutes and then I'm gonna go back to stepping over this. That felt very, very long. I think it's just because of the coffee. So I'm gonna continue to step through the stuff here. I think probably is worth doing the flowchart for this stuff as well. Might do that off stream. Yeah, the main thing that I want to understand is how they structure the physics engine and how they synchronize the physics engine. But I think it's just always the same pattern. It's just all these libraries use event emitters, and then they use flag variables. And then based on the events that it emits, it updates the physics, and then right after it updates the physics, it does a redrawing of everything. That's how we do it. It does it. But I think here they are using just normal positions and not forces. I think they don't use like a physics engine, they just change the positions to emulate forces. And it's like the most difficult thing is deciding which thing to use. There's just so many libraries and frameworks and things that are changing all the time. And another thing that I'm thinking about is probably I should move everything to classes as well instead of using functions, because all of them use classes. So, but I'm not really sure why that's the case. Because there's just the whole thing about object-oriented programming versus the other paradigms, and most people I think don't like object-oriented programming. So I'm not really sure, but it seems like for this kind of stuff it's better to have classes. So I probably should create a bunch of classes instead of using functions. And then just do it the same way that they are doing here, using event emitter to structure the events and the functions that are gonna happen. So they use drag ends, drag starts. And flag variables. I think I'm just gonna write down here. Maybe I should just copy everything from VisJS, and because I already have the functions for drawing the nodes and the edges, so I just should copy everything and just change the, instead of using the canvas and canvas render events, I just set up the custom ones on my own. I want to see if I can do it without using the emitter though, because it's easier to understand if I don't use the event emitter. And also I want to, because the thing is I want to keep it as like concise and simple as possible, so I don't want to put everything. I think I just want to, I think that this is the issue with just copying the libraries, because I want to make sure that I'll only add stuff that I'm gonna use, and then because I want to understand how everything works. I don't want to just copy, because later on I'm gonna have to change the functionality anyway to do the stuff that I want to do. So I think I can't really just copy everything. Just I have to put only the stuff that I think I'm gonna need for now. Maybe we should just write all of the events and then write the functions that get triggered by all of them. Maybe not write. I think I'm gonna do that off stream. That's a good idea. I'm gonna go over this again off stream, and then I'm gonna do the flow chart here. I'm gonna put the event, and then I'm gonna put all the functions that got triggered from that event and what file they happen. And that way I'm gonna be able to, it's gonna be a lot easier to put the breakpoints here. And also to understand the whole flow of logic that happens after the event gets triggered. I think that's probably the best way. And then from that, I just copy whatever functions I think I'm gonna need to emulate the events that I want, the drag and the zooming mainly. And also, so the main things that I want to figure out for now is the zoom, the drag of the canvas, and how to make the selection work without being this buggy here when ideally you would always be on top of the mouse until I let go. That's the thing. And obviously I'm gonna have to change the zoom and the drag as well. And this is the difficult part, because it has to work with Pixie, and here it just changes. They just change probably the context of the canvas. You just redraw everything on the cycle there of the animation, but with Pixie it's gonna be different, I think. It's gonna be the same, but different. Probably, yeah, I have to mix the Pixie viewports functions as well. So the way that they do it with Pixie viewports so far that I understand is that they just use the point class from Pixie to get the coordinates, and then they use the event from Pixie. Because, and this is the thing that I think I'm gonna change as well. I think, yeah, I tried to pass the viewport to set up the events on the viewport, but it wasn't working because the structure of the thing, I wasn't being able to. I tried to put the elements inside of the viewport instead of appending them to the stage, but for some reason they weren't drawing when I tried that. So maybe it's better to just implement the Pixie viewport stuff first, and then remove whatever is necessary to incorporate the VisJS way of doing. I was copying I think I'm gonna do that. I copy the functionality of all of the stuff that Pixie viewport uses, and then just call these functions here inside of the events that I have here to see if it's gonna work, if it's gonna change. But I think it's like a lot simpler than it seems it is. The thing is that the Pixie viewport doesn't change the physics. That's the problem. So when it comes to physics, then I have to see on the VisJS how it does it, to update everything. But I think that I already know like the path to do it. It's just gonna be doing the logic that, because Pixie viewport doesn't do a lot of stuff as well. I think that the main calculations are done by the event system from Pixie, and all that Pixie viewport does is just change the values It just does some simple calculations to change the scale, the x and y values of the container that Pixie viewport is, and then based on that, it's gonna change the view. And Pixie handles the other calculations based on the classes that it has. But then the issue is how to update the physics, but it's probably not that complicated. Just loop over all the nodes and the edges and just create the values again. So, but it's more difficult. The difficult part is not figuring out how to do it, is thinking about what is the best way to do it in the context of the whole thing. Like, should I structure everything in classes? Like, maybe it's better to change the functions that I have here in the beginning, because the way that I'm thinking about it now is different. Because these functions are done to only run once on the initialization. And I think it might be better to translate everything into a class and then make the functions in such a way that I can call them each time that the event happens. So this node factor here, for example, instead of doing like this, I have to structure them in such a way that... But maybe I have to... This is another thing that is interesting to see how VisJS does it in the beginning of the layout, how it decides to position every node. Because here I'm doing randomly, obviously. But it would be good to have, I think, a function that allows me to just pass the positions and then sets everything up again. Because the way that I'm thinking about it, that I should do it, is just change the size or do whatever calculations I have to do to change the drawing, the visualization of the canvas based on the Pixie classes. And then after that, I just pass the same values of x and y to these functions here. And then based on those values, it recreates the nodes and the edges. So it has to maintain all the properties, but just change based on the magnitude. So for example, the radius of the collider, it should change by the same proportion that the zoom is going to affect the drawing. So, like, and this is the part that is kind of difficult to think about, because like, how do I structure everything to be dependent on the same variables so that the flow of information works there with the events, and the flag variables to set up the breakpoints on the inside of the events of when each thing should start and stop. For now, I'm just gonna step over, and then I will do the flowcharts off string. And I think I'm just gonna copy the functions off stream as well. I'm gonna copy the Pixie viewport functions through here. And then I'm just gonna call these functions inside of these events here to see if the effects work. And then after that, I'm gonna do the flowchart for VisJS, and then I'm gonna... I have to understand how the physics on VisJS changes based on the events, and then I merge the two. I try to emulate as much as possible the physics from VisJS, and try to emulate as much as possible the change in visualization from Pixie viewports, and that's going to allow me to bridge the gap between the two, I think. And I'm probably going to have to change everything to a class as well, which I'm trying to avoid, but because I think it might be better to leave everything as a function, because later on, like, once I finish this and then I work on the other parts of compiling everything and then creating the graph, I think it might be better to leave everything as a function, because it's going to allow me to create different visualizations, I think. It's going to make it more flexible, but maybe it's not really necessary, because it's always the same. And maybe it's only better to leave as functions if I want to do like a different type of visualization instead of just graph visualization. But that might be the case in the future as well, because I don't know, like I don't even know if it's going to be useful or not. Sure, the stuff that I'm thinking about doing. So like maybe once it gets to the point, I decide to pivot into something else, and then it might be useful to leave everything as a function, so I can create different types of visualizations instead of just graph visualizations. Like I think there's a bunch of different things that might be interesting to visualize as well. I don't understand really well how this works, but I know that it's for the selecting what's going to be displayed there to customize the visualization. But I don't understand very well how it works. Configurator, set modules. Yeah, so it just creates the object and then passes everything. Copies the options for each class instead of this object here. and then it passes through this function, set module. But then how does it do that jump here? So the configurator is this object, I think. Yeah, it's probably this. But I don't understand really well. Like, why does it go from here to the other? The way that I'm thinking about doing is just a React component, and then I'm gonna use this type probably, however you say this, to handle the context, and then I make a context show all the variables that are gonna be used to customize the thing, and then I'm gonna pass as an object as well, the same way that they do it, as an options object, and then inside you select everything, and then you put the default values, and then it also, inside of the component, you receive as props or use the context to select what's gonna be, what each value is gonna be. The problem with this is that I don't wanna skip, and I don't know how long it's gonna go. Based on what I saw from the classes here for VisJS, I think they just changed the values of X and Y. They don't have physics, like a physics engine. But obviously the physics engine is going to be doing the same thing under the hood, but oh fuck. So it doesn't go here. Let's see. Maybe if I put breakpoints here as well. I can't put breakpoints. I'm gonna put whatever I can here. Maybe it's gonna stop at some point. Like before it creates the network class. Because this is the file that is used to create the data. And then it's gonna use this in several different parts, I think, on the code. Yeah, but I can't put breakpoints here. I think another thing that I can do is based on the names, because I've seen there that uses some names that are the same on the physics on the wrapper.js, like damping for the values. So I can just emulate the, like look for the names on the wrapper.js, and then just try to do the same stuff by using the wrapper functions instead. I need to pay attention so I can put breakpoints. So next time that I do this, I don't have to go over all this stuff because it's not important to me. Because obviously I'm gonna have to change I'm gonna have to draw in a different way. So the only thing that matters to me is the physics and the events from VisJS. I think I have to go over all of them. Maybe I stop here and continue to do this off stream. I think I'm gonna stop here. I'm gonna continue to do this off stream. I'm probably not gonna stream for some time. I'm gonna do the stuff that I said that I was gonna do, of creating the flowcharts and trying to implement the functions from Pixie viewports on the stuff that I have there. But I think I am like going through some paralysis by analysis, because the biggest problem is deciding which way to structure things. I think that's what is like preventing me from trying to do this stuff, because it's hard to decide what direction to go, to structure everything, because there's a lot of stuff going on. So this is just gonna be annoying because I have to go 60 times and I can't control the size of the nose because it comes from the thing, unless I do my own stuff. But then it's annoying because I have to set up everything. I'm thinking about, I'm trying to clarify in my mind what exactly is blocking me from building, because I think it's not that difficult to build events. It's just very simple calculations, but I think it's hard to think about the way to structure, because there's so many different ways to do it. And the issue is that it's related to the way that I'm gonna receive the data, which comes from the graph, which is based on the way that I'm gonna set up the visualization. I think that's the stuff that is blocking me the most. And also clarifying here how the selection works. because the selection is connected to the data. That's the problem. The edges and the nodes, and the way that they structure the edges and the nodes here, and the way that is related to the physics. I think probably the best thing to clarify now is I need to create the flowchart of what functions are triggered by what events. I think once I have that more clear in my mind, then I can understand the logic. The second thing is the difference between the VisJS physics engine and using wrapper.js. So how are they creating the model of the physics on the objects? Like, how do they create mass, velocity? The spring force already know that they saw. And what are the differences between that and using the wrapper.js? I think that's and it's kind of difficult because wrapper.js is like a black box, because I don't understand how the source code works. So I think that's another thing that is kind of blocking me, because I have to think about how I'm going to translate the VisJS functions to wrapper.js, but I don't understand really well wrapper.js yet. And then it's hard to decide whether or not to build the projects from scratch using wrapper.js so I understand more how the functions work. But it kind of feels like a waste of time, to some extent, because the names are self-explanatory, I think. Yeah, so maybe the first thing that I have to do is just clarify. And what is the other thing? I think before all of this I should probably implement Pixie viewports functions. I just put the same name on I create the same events. I'm just gonna change, instead of attaching the events to the canvas, I'm gonna pass the app stage, I think, which is a container. And I think that's one of the differences that's in the way that I'm doing there and the way that Pixie viewport does it, is that I'm attaching the events on the canvas. And when you attach the events on the canvas, it's not going to trigger the event system from Pixie.js because it's not a class inside of the system. So I think that's the way to do it, is to put the events on the app stage, because the app stage is a container class. And then what's going to happen is that the event system is going to be triggered first, the event on the event system. And then they are going to call all the functions that translate the normal event into the class that Pixie.js uses, which is the federated root event. That is more powerful because it has more information that is related to WebGL. So then if I do it like that, then the functions that I set up there are going to receive that event, the Pixie.js event. And then I just call the same functions that Pixie viewport calls it, and see if I can change the visualization based on that. That's the first thing that I think I have to do. And then the only thing that I'm going to change from the Pixie viewport is the element that it changes, because Pixie viewport changes the container class of Pixie viewport, the sizes. It does everything based on this.parent, which is the viewport class, which extends the container class, which extends the display object class, which is the stuff that changes the visualization. So instead of changing that class, I'm going to try to change the app stage directly. Then yeah, regardless of whether or not that works, I think I'm gonna move on to the other step, which is to clarify to create the flowchart based on VisJS. And then after that, I try to clarify the difference. Yeah, after I'm done with the flowchart, I go through each function on the flowchart that is related to the physics, and then I write down all of the physics values, formulas used on VisJS, and see if there is an equivalent or similar on Raptor.js. And then based on that, I'm gonna know the differences. And then only then I think is worth thinking about whether or not I should change everything to a class and then try to emulate the same pattern that both libraries use by creating a class, extending to event emitter, and then setting everything up with the event emitter instead of doing like I'm doing now, which is a function that has all the events. I think the reason why they use event emitter is probably because if you do it like with a function like the way that I'm doing, I have to pass the same element and then I have to attach the events to the same elements. But if I use with event emitter, then because the event system is going to bubble up or it's going to trigger each event regardless of where they are triggered in the visualization because of the functions that it calls. So I think it's more flexible to use the event emitter class. But I think I'm gonna try to do it with the way that I'm doing first because it's easier to understand what's going on. And then if it doesn't work, then I go back and change. And that's probably the best way. Because I feel like I'm making progress, but part of me thinks that I'm kind of on a paralysis by analysis because it's hard to decide which way to go. I don't want to be stuck. But at the same time, I don't want to start doing a bunch of things and then I have to change everything later. Because what's the main goal here? The main goal is to understand how is the visualization related, synchronized with the physics engine. That's what I'm trying to clarify. So I can break down Pixie later on and then synchronize everything from scratch. So the structure of the whole system is the thing that is difficult to think about. What is the best way to set up all the functions in such a way that whenever the positions change, it's going to synchronize the physics and the visualization in a way that is easy to understand what's going on. I think that's the goal. So to understand that, I have to understand the whole pipeline of Pixie.js, the whole visualization pipeline, which involves the ticker thing, and all the classes that are going to be triggered when there's a redrawing, and how the events are set up on Pixie to structure the redrawing, the graphics pipeline, and then how VisJS structures the physics engine pipeline, so I can merge the two of them. It's kind of like a gradient. On the left I have Pixie.js, on the middle I have Pixie viewports, and then on the other side I have VisJS. I'm trying to bridge the gap between the two. Yes, probably following the steps here is the best thing to do, because that's gonna hopefully take me out of paralysis by analysis, and then slowly I'm gonna be able to build and modify things so that it works. I think I'm gonna do that off stream. I'm gonna continue to stop over this, and the first thing I'm gonna do is just follow this step here, and then after I do that, I'm gonna... The issue is that if this thing doesn't work, because then it's gonna be a problem. That's my concern. But I have to test it first. Then I decide what to do. Because if this doesn't work, then it's gonna be annoying to figure out what to do next. But I'm gonna follow these steps here off stream. And then I'm probably not gonna stream until I follow everything. So I don't know how long it's gonna take. But yeah, hopefully next time I'm gonna have all of this figured out, and then I can continue from here.